Two masses M1 and M2 in kg are attached by a massless string. How do you determine tension and acceleration? Assume no friction. Assume masses M1, M2, and the angle theta with the horizontal are known. So how do you determine tension and acceleration in terms of masses M1, M2, and the angle theta? Again, welcome to HDTVEDU.com, direct and simple education in seconds. So we have two non-zero masses. So we isolate those two non-zero masses and look at the forces acting on those masses. All right, so we have the mass on the inclined plane, and you have the gravitational force vertically down, and that gravitational force can be replaced by a horizontal component and a vertical component. All right, so this is W, and this is W parallel. Okay, so weight can be replaced. The vector, the gravitational force vector, can be replaced with the parallel and the perpendicular components. All right, let's assume this is X and this is Y. Okay, now this is mass M1. So let's replace the gravitational force vector with the parallel and the perpendicular component and redo the forces acting on the mass. What else do we have? We have the tension to the right, and it is accelerating to the right. That means tension has to be greater than any forces to the left. I mean, to the right, there's only one force, that is the tension. And what else is missing? The normal force, right? So we have the normal force. All right, normal force. And now you say this is X and this is Y. Net force along the horizontal equals M1A. This is mass M1. All right, net force along the horizontal equals M1A. So what is the big force? T. What is the small force? W parallel, and that equals M1A. Net force along the vertical is equal to 0. There is no acceleration along the vertical. So you say normal force equals W, normal force equals W perpendicular. Okay. For the mass M2, what do we have? For the mass M2, what do we have? We have the gravitational force stronger than tension. So net force, remember this is X and this is Y. Net force along the vertical equals M2A. So which force is greater? It is accelerating down. So which force is greater? M2G. So M2G minus T equals M2A. All right. Now let's put all these equations on one page for the first mass M1, we have T minus W parallel equals M1A. For the second mass, we have M2G minus T equals M2A. So now we add, and what do we get? M2G minus T plus T minus W parallel equals M1A plus M2A. All right, you see negative T, positive T cancels out, so you get M2G minus W parallel equals, A is common, so you say A times M1 plus M2. Now this is how far you can go at 100 level. Now let's see what happens at 200 level. At 200 level, here is the mass, the gravitational force is this, and that can be replaced with a parallel component, and that parallel component equals mg sine theta. This is theta. And then there is a perpendicular component, and that perpendicular component equals mg cosine theta. And then you have the normal force, and you have the tension. So net force along the horizontal equals M1A. So you say T minus W parallel equals, so T minus W parallel equals M1A, or you say T minus W parallel M1G sine theta equals M1A. All right. For mass M2, what do we have? M2G minus T equals M2A. So you have these two. So we have these two, and when you add, what do we get? M2G minus M1G sine theta equals A times M1 plus M2. So we get M2G minus M1G sine theta equals M1 plus M2 times A. So what is A? G times M2 minus M1 sine theta divided by M1 plus M2. And once you have A, substitute back into M2G minus T equals M2A. So what is T? M2G minus M2A. So once you have A, substitute back into this.